Hello everyone, welcome back to Skill Talk, where we turn industrial knowledge into the practical learning. So in today's video, we will perform some real world vibration calculations using some machines, taking some examples for the machines that are running at RPM of 1000, 1500 and 3000. So why we have selected these three RPMs? Because most of the machines in the industries you will find running at these speeds. So what we'll do now, we will be doing the calculations for the frequency, time period and amplitude, and also understand that those numbers actually means what it means in the real machines, right? So overall you can say that this video will be a kind of a practical example for the theory that we have learned in our last videos, that is the principles of vibration. Okay, so let's revise first basics that we have already already discussed in our last video. So what is the frequency? So frequency means the number of vibration cycles per second, or it is measured in hertz or CPS. So the second is the time period that we have discussed last time. What is this time period? That is the time taken for one complete cycle. Okay, it's opposite of frequency. It's measured in seconds. So, and the last one is the amplitude. So amplitude is the maximum displacement from its mean position, that is mostly measured in the microns or mils, right, or mm. So these are the you can say the three building blocks for the entire vibration analysis. Now we'll be using this and we'll try to see that how we can use these terms or use these calculations in our real world examples. So now let's start with the simple calculation, that is the converting RPM to the frequency. Okay, so let's say that machine in the industries usually have their own speed mentioned on their nameplate. Okay, so if you are going to monitor any kind of a motor, so it's already mentioned on their nameplate that what is the speed of this machine or what is the RPM of this motor, right? So what is this RPM? It's the revolutions per minute, or you can say the rotations per minute. So but for for vibration analysis we deal mostly with the frequencies, that is measured in the hertz. It's also known as the CPS. Don't get confused between cycles per second and cycle per minute. Okay, cycle per minute is equals to the RPM and cycles per second is nothing but it's hertz. Okay, so if I want to calculate the frequency, so what will be the formula? It's very simple, that is F is equals to RPM divided by the 60, right? So here I'm showing you one table that is let's say that if your machine is running as the 1000 RPM, then what will be its frequency and how you can calculate the time period. So it's very simple. Let's take one example, that is the first one, that is the 1000 RPM. Okay, let's say that my machine is running at the 1000 RPM. So if I want to calculate the frequency, so what I will do, just simply divide it by 60. So 1000 is my RPM and divide by 60, that I will be getting in the hertz. Okay, so let's say 1000 divided by 660, how much it will be? It will be 16.67 hertz. Now let's say I want to calculate the what will be the time period for this. So we know that what is the time period? Time period is it's just the opposite of the frequency. So what we'll do, 1 divide by whatever the frequency that we get. What is the frequency that we get? 16.67. So 1 divided by 16.67, that will be equals to 0.06 seconds. That means to complete the one rotation, this machine is taking 0.06 seconds, right? So in the same way you can calculate for the 1500 and 3000 RPM. I am showing it here on the screen. So I believe you can do this calculations. It's very simple. So overall what we get from here is this, that let's say that my motor which is running at 3000 RPM, so that will be completing around 50 vibration cycles every second, right? While that my another machine that is running at the 1000 RPM, that will be completing around 17 cycles per second. So that's why high speed machines vibrate more rapidly even if the amplitude is smaller. So that's the reason that we always consider the frequency of the machine, or you can say the RPM of the machine. And it's not like this that simply I will calculate the amplitude, that this machine is having the 2 mm per second vibration, the another machine is having the same 2 mm vibration, so both the machine condition is same, because I also have to check what is the frequency or what what is the RPM of that machine. So based on that, the criticality level will be decided, right? So now the next we will be understanding the amplitude. So okay, let's talk about amplitude. So what is this amplitude? That how far a machine part moves from during the vibration. So let's say in the low speed machines, so let's say example of 1000 RPM. So here the vibrations are large in the movement. That means you can slightly see from your visible eyes the movement of the machine. Okay, so you can see, and normally we can see it and also we can feel them. But if same case, if I will discuss for the high speed machines, that is a 3000 RPM, let's say, or more than that. So what will happen? The vibrations are so fast and so tiny in the movement, it's hardly visible with our naked eyes, right? So overall, what this means, that if the movement is tiny, it doesn't mean that vibration is not critical, or you can say the force that is acting inside this machine is not critical, right? Because we have to consider the frequency also along with the amplitude. So amplitude is mostly measured in microns, that is micrometers, that is for the displacement, and mm per second or inch per second for the velocity, or you can say meter per second square or the g for acceleration. Now let's take one practical example. Let's assume that there are three motors. Okay, there are three motors and each motor is running at different RPM. Motor A is running at the 1000 RPM, which is having the displacement of, let's say, 0.25 mm. The second motor, that is the motor B, that is running at the 1500 RPM. It's having the amplitude of, let's say, displacement of 0.15, and the last one, that is the motor C, that is running at 3000 RPM, is having the displacement of 0.05 mm. Now even though the 3000 RPM motor, that is the motor C, it's moving very less distance, but it vibrates faster. So overall, what does this mean? That the energy involved can still be high in comparison to the motor B and motor A, right? So that's why we are not judging any kind of a machine. We don't judge any kind of vibration just by amplitude. We always have to look after the combination of the amplitude and the frequency. I hope this point is more clear by taking this example. Okay, so now we will be having the quick check, or you can say that quickly we will be seeing that how we can calculate the velocity and acceleration, because normally you have seen in your vibration analyzers that you are getting the velocity and acceleration. So we will be discussing that how basically it is get calculated using the SHM calculations, or you can say the simple harmonic motion formulas. Okay, so using the SHM, we know that the velocity formula is known as the 2 pi fa, that is the 2 pi, f means frequency and a means amplitude. Same way for the acceleration is the 2 pi f square a, that is the same, f means frequency and a means amplitude. So it will be more clear, don't get confused. Now it will be more clear. Let's assume that there is a one machine, or you can say our motor B, that is running at the 1500 RPM. So what will be the frequency? I believe you know that how to calculate the frequency. That's simply divide 1500 by 60. So once you will divide 1500 by 60, you will be getting the frequency, that is the 25 Hertz. Okay, and now let's assume that the amplitude at which this machine is vibrating, or this machine is moving, so is 0.15 mm. Okay, or you can say that 0.00015 meter. So here we did the calculation in the both, that is a meter per second square per second and mm per second, so that it will be more clear, but you can just focus on the mm per second, right? So let's calculate first velocity here. So what is the formula for the velocity? Velocity formula is 2 pi fa, right? So what is 2 multiplied by pi multiplied by what is our f? F is 25 Hertz. So f is 25, and then we'll be multiplying it by a. What is our a? Is 0.15, right? 0.15 mm. If you want to calculate in meter, then you will be putting 0.00015 meter, right? But now we will be calculating in mm, so we will be using 0.15. So what will be the output? Or the output, if you calculate this, you will be getting somewhere around 23.6 mm per second, right? This is what we have calculated. You can also do your calculations. In the same way, if you will calculate the acceleration, so now what is the formula for the acceleration? Is 2 pi f square multiplied by a, right? In the same way, we'll be putting f is equals to 25, and also the amplitude is equals to 0.15, and here you will be getting the acceleration, that is the 37 meter per second square. So what does it mean? That the motor parts are here accelerating 37 times every second, which is a kind of a, you can say, the lot of mechanical energy. So now we will be comparing by calculating this velocity and acceleration for all of our motors. That is motor A that was running at 1000, motor B that was running at 1500, and motor C that is running at the 3000. Okay, so let's assume first we will be calculating the frequency. Here you can see the table. So first you will be calculating the frequency calculation is very simple. For the 1000, divide by 60, so we'll be getting 16.7. in the same way you will be getting 25 for 1500. In the same way you will be getting 50 for 3000. Now you can calculate the time period. What is the time period? It's the reciprocal of the, or you can say the reverse of the frequency. That means for 1000 it will be 1 divided by 16.7. in the same way for 1500 it will be 1 divided by 25. in the same way for 3000 it will be 1 divided by 50. Okay, so remember that we have assumed the amplitude in our previously, that the amplitude for the 1000, that is the motor A, will be 0.25, and motor B will be 0.15, and motor C will be 0.05. okay, so now if you use the same formulas that we have used above, so what you will be getting? You will be getting the values of the velocity and acceleration in mm per second and meter per second square. So here you can directly see this is what we have calculated. So here you can directly see what are the calculations. Let me give you a one kind of a challenge, or one kind of a questions. So I hope that you guys will calculate and reply to in the comment section, right? So the first question for you, please take a note. The first question will be for you that let's assume that your machine is running at 1800 rpm now. Okay, and you have to calculate the frequency and time period in the same way that we have calculated now. And the question 2 will be, let's assume there will be one fan or motor that is vibrating with an amplitude of 0.2 mm and it's running at 25 hertz. So for this machine you have to calculate and write the answer in the comments for the what is the velocity and what is the acceleration for this, right? Now in the third question, that is a little bit tricky. So here is this, that let's say that there are three machines, motor A, motor B and motor C, that we have taken already example for that. Motor A is running at 1000, motor B running at 1500, and motor C running as a 3000. So what do you think that it's most likely to have a resonance in the weak structure, and what is the reason for that? So guys, try to answer this in the comment section. If any confusion or anything is there, please mention in the comments. We can discuss and we can take on a separate video for that, right? So guys, keep practicing these calculations because it's very important for the vibration analyst. As more accurate you will be with the calculations and with the basics, believe me, your vibration skills will drastically increase with that. So thank you guys for being with us. Please don't forget to put your answers in the comment section, and if you need any kind of a video that you think, or any kind of a topic that you think that you didn't understand, please mark a note in the comment section so that I can make a separate video on that. So thank you guys. We'll meet you in the next video of this vibration series. Till then, take care. Bye.